So this is our second video for the next chapter. In the first section, we're going to talk about force,
Net force,
balanced forces,
unbalanced forces,
and friction. So first, we're going to talk about force. Force is a push or a pull on an object or like a person. It's just a push or a pull in general. We're going to demonstrate force. I'm just going to push her, and that's going to be the force that I apply on her. Ready? That was a force that I put on Isabel. Next, we're going to talk about balanced forces, and balanced forces are two or more forces exerted on an object, and if the forces are balanced, the net force is 0. Now we're going to demonstrate balanced forces, and we're going to use a door, and she's going to be on the other side, and I'm going to be on this side, and we're going to both put forces on the door, and it's not going to move because the forces are balanced. So, okay, ready? Ready? See, the door's not moving because the forces are balanced.
Now we're going to talk about the friction and the different kinds of friction. Friction is a force that nearly brings everything to a stop. So these two surfaces will touch and it's friction, and when it rolls it stops.
The next kind of friction we're going to talk about is static friction. That's when two things stick together. So, for instance, a balloon and a head. You rub the balloon on the head, and then the hair will stick to the balloon because of static friction.
Rolling friction is an object rolling across a surface. This object will roll across the surface because of rolling friction.
And it stopped. And the next friction is sliding friction, and that's when an object slides across the surface, and sliding friction slows down the object that's sliding across the surface. When I put on the brakes, the wheels would slide because they're not rolling anymore. They're sliding because the brakes stop the wheel, so it's sliding across the concrete. We'll talk about weight, and weight is the size of gravitational force exerted on an object. And so, explaining that, we would have something heavy and something light, and we would show that the heavier object had a bigger gravitational force. I have a weight.
I have a sock.
And obviously the weight would have a greater gravitational force.
Gravity explanation would be the force of gravity exists between two objects that have a mass. We're going to throw this and it's going to fall to the ground because of gravity.
We're going to talk about air resistance, and air resistance is the form of friction that slows objects moving in the air. So a cotton ball and a rock, a cotton ball would hit the ground first because, a rock would hit the ground first because cotton ball has greater air resistance.
For the last section, we're going to talk about Newton's three laws.
First law, if the net force acting on an object is 0, the object will remain at rest. And if the object is already moving, it will continue to move in a straight line with a constant speed. Okay, so I'm going to pull this, and the object will remain at rest when I exert a force on this.
The second law of Newton's law is acceleration of an object is net force divided by mass.
And we're going to push on it, and then we're going to find the acceleration of the acceleration of the door. Ready? So the net force is 0 because the forces are balanced, and so the net force is 0. So 0 divided by like 15 pounds, and you'd get 0. The acceleration is 0 because it's not moving. Third law of Newton's law is forces always act in equal but opposite pairs. So we're going to push each other, but we're not going to move because the forces always act in equal but opposite pairs. Okay, ready? See, we're not moving.
Really?
And that's the end of our science video.